We're going to talk about the recycler view. We're going to motivate its necessity, and then we will look at its implementation. In Android, the standard adapter views, such as a spinner, can sometimes necessitate the creation of a custom adapter. That is an adapter that extends the base adapter class, as an example. And in creating a custom adapter, you are expected to provide implementations for all of the necessary callbacks. One of those callbacks is the getView function that is charged with returning a view that gets displayed inside the adapter view. Now, there is an expectation that the implementer of that function will incorporate what's called the recycle pattern, where a previously used view can be passed to the function as an argument, and that view, if provided, should be populated with new data rather than having a new view being created. The problem is that while this recycle pattern is expected, it is not enforced, certainly not by the framework. So it's very easy for developers to simply ignore the recycle pattern, create new views every time getView is invoked, and that can have a deleterious effect on the performance of an application. It presents as slower to the user, there could be stutter, there might be a lack of responsiveness. In part due to this potential ignoring of the recommended implementation of custom adapters, Google introduced a new view type called RecyclerView, which is not an adapter view in the technical sense, in that it does not extend the adapter view class, but certainly it behaves like an adapter view, and we treat it as in a similar form. And in fact, it performs the role of the now deprecated list view and grid view objects, where you're able to present elements in a scrollable list. So the recycler view essentially forces your hand as a developer by ensuring that you implement the recycle pattern, because the recycler view's adapter class essentially separates the responsibilities of creating a view and populating that view with data into two separate functions, whereas the standard base adapter implementation, when you're creating a custom adapter for, say, a spinner, it had those two responsibilities in the same function, which is why it was easy to ignore the proper implementation. So the RecyclerView's adapter does this using something called the ViewHolder pattern. Essentially, to create or implement a recycler view, you are focused on a collection of classes. First, there is the recycler view itself, which is, of course, what the user will see on their user interface. There is the adapter class that serves as the generator in a sense. There is this view holder object that we will specialize to hold view items, and you're going to see how that plays into the whole recycle pattern in a few minutes. And then we have a layout manager, and the layout manager is responsible for determining how the views are presented inside the recycler view. And, on a technical level, it's the layout manager that is going to be invoking the various functions that we are going to implement inside of the adapter. Let's look at a basic implementation. What we're going to do is create an application that can display a list of images, and we're going to do that by using a recycler view. So the first thing I'm going to do is I'm going to add some images to my application as resources. So I previously downloaded a set of images, and I'm going to use the resource manager of the IDE to import these images. So from the resource manager, I'm going to click on the little plus toolbar button and select import drawables. This term drawables refers to the ability of a resource to be drawn on the screen. This can mean our standard images such as JPEGs and PNGs, etc. But they can also refer to various XML-based image formats where the image is described and you get this ability to scale the images and other things. So that's why we say drawables versus images, because they're not necessarily your standard image formats. So here I have a set of images. So these are my favorite deserts. So I'm going to import a set of images. I'm not modifying anything about them. I just want to add them to my project. So I'll hit import. At this point, I can actually see these set of images in my drawables resource folder. From here, I can take these images and place them or display them in an image view. They will have the ID r.drawable. Whatever the name of the image is without the extension. So in the case of this first image, if I wanted to access this particular image in my code, I would use the reference r.drawable.antarctic. Now, instead of having an image view directly in my layout, what I am instead going to do is place a recycler view in the layout instead. This recycler view, I am going to apply the necessary constraints since it is within a constraint layout. And I'll give it the ID recycler view. Now that it's available, my intention is to generate a set of views. So I'm going to create an image view in code that will be displayed in this recycler view using a recycler view adapter. So we've got a few steps that we have to follow. First, let's do the simple stuff. I'm going to wire up my application so that I can access my recycler view from code. So I'll switch over to my activity. I'm going to have a recycler view variable. And then I will reference the RecyclerView object using that variable. So that's step one. That's the easy part. Now we have to do a few things. Essentially, for our RecyclerView to function, it needs to be given an adapter that will generate its views, and it needs to be given a layout manager, which will tell it how to lay out the views that are generated by the adapter. Creating the RecyclerView adapter looks very similar to creating a base adapter implementation, where we essentially give it all of the necessary pieces to do the work it needs. Generally, that means giving it some collection of data that it can use based on its rule set that we will define to generate views. And you may also realize that in order to generate views, it may need context, etc. Turns out we may not need to pass in a context object directly. Rather, as you'll see in a moment, we will have access to a context object inside of the adapter class. So in the meantime, what we'll do is the simple part, which is we'll create the collection of data that the adapter will use to generate its views. In our case, that's going to be an array of integer values. Now, the reason it's an array of integer values, it turns out, is because at the end of the day, all resource IDs map to integers. So if you're ever concerned about the type that you're operating on when you're dealing with resource IDs, they're always going to be ints. So I'm going to create my collection of images that will simply be an array of, and then I will list all of my images. So in this case, it will be r.drawable.Antarctic. And then we'll repeat this for all the types, or rather all of the available images. So since I'll have to repeat this part, I'll just make a copy. It's Arctic. Not that the order matters, but by keeping it in alphabetical order, at least I can keep track of where I am in the list. So now we have Gobi, Great Victoria, Mojave, Namib, Rubal Khali, Sahara, and Dar. And there it is. And so now I have an array of images, or image resource IDs, which will allow me to access the images. And I will pass this collection of images to an adapter. So let's go ahead and create our adapter. So to do that, I'm just going to create a class. So I'll create a new Kotlin class, and I'll call this class image adapter. Once it's created, I now need to specify that this particular class is going to extend RecyclerView.adapter. Now, there are a few steps that I'm going to need to follow here to have this class be complete. Because it turns out when you're creating a RecyclerView adapter, there are certain things you need to specify. The first thing we need to specify is a generic reference. Specifically, a RecyclerView adapter wants a reference to what's called a ViewHolder class. Now, the ViewHolder class is defined inside the RecyclerView. So we could, in theory, go ahead and just pass a reference to the ViewHolder in the base class. However, the proper usage here actually requires that we define our own specialized ViewHolder, which is then passed as a reference to our RecyclerView adapter generic. Now, this does in fact become a little clumsy because it feels like we have to go and define another class before we can fully implement the outer class. But once you've done it a few times, it sort of becomes, if not second nature, at least straightforward enough that you won't be concerned about the order in which we're doing things. So before we go any further with our own adapter implementation, we're going to create another class for a ViewHolder. And to differentiate this so you can see the difference, I'm going to call this class image ViewHolder. And this image ViewHolder is going to inherit from RecyclerView.ViewHolder. Now, the job of a ViewHolder is to hold a view. Essentially, this separation that I mentioned earlier of creating a view versus populating it with data is accomplished inside of a recycler view by essentially the framework asking you to create your set of views independently from asking you to place data inside the views or set the properties of those views. In order to do that, regardless of how simple or complex your views happen to be, the framework simply asks you to place your views inside of a container, a generic container that it can pass around because it understands the container, even if it doesn't understand your specific views. So that's what a view holder is. At its core, it has a constructor that will take the view elements that it will hold. This can be a single view, or it can be a layout that contains multiple views. Either way, that's what we're going to pass in here. So this can be essentially any view that your own image view holder is, or that our image view holder is concerned with. So what we're going to do is define what type of view our image view holder will accept, and then we'll pass that same reference to our base class's constructor. So in our case, we intend to generate image views. So my view here is going to be an image view. And I'll just take that very same image view and pass it to the view holder constructor. Once that's done, I now need to enumerate inside of my image view holder all of the view types or all of the views that will be stored or are housed inside of the image view holder, inside of this container. If this were a layout that I was passing in, then I might have to enumerate all of the views inside the layout. In this case, I'm actually passing in a single view. It's just my image view. So the only thing I need to reference here is the image view. Now, just keeping with tradition, I'll put an underscore here to differentiate between the parameter that I'm defining and the property inside the class itself. So here I can now have an image view, which will be initialized with the argument that's passed in. So I now have my image view holder defined. It is this simple. It's just a container. We're going to see later on that we can actually do more with this, expand it when we get to things like interactions, but we'll talk about that at another time. What we can do now, however, is now that we've defined our image view holder, we can go back to our image adapter definition by giving this base class everything that it needs. So what it needs here is a reference to the view holder that we've defined. So for us, that is image view holder, which will take the full image adapter.image view holder qualified name. And this actually wants me to specify that we are invoking the primary constructor. Now, at this point, we have gotten to the place where the IDE can help me out. What this is telling us is our class is incomplete. It's incomplete because we're referencing a class, a RecyclerView adapter, that it turns out is itself abstract and it has a few functions that need to be implemented. Now, this is why it was important for us to place our own view holder reference here. Because this generic reference is what is going to be used to complete the rest of our image adapter class. So I'm going to have the IDE help me out by implementing the members, specifically these three functions: onCreateViewHolder, onBindViewHolder, and getItem. When I hit enter to select those, I see that I have these three functions that are waiting for me to implement them fully. But what I want to draw your attention to are the types that some of these functions are actually operating on. On create view holder, its job is to return an image view holder. That's literally the type I just defined here. The reason this is done is because, of course, I pass in a generic reference to my image view holder. So that's used to complete the rest of the class. Similarly, on bind view holder accepts as an argument an image view holder. So had I used a generic view holder reference here, yes, the class could still have been valid, but all of these functions would have been operating on the generic view holder base class. And what it would mean is I would have to cast in order to use my specific view holder inside of the implementation of these functions. But by using my reference as the generic reference, it means that these functions are operating on my type. So I'm going to put this function just for completion at the end so that I can operate on these things in order. So the first thing that I need to do to have this adapter essentially do anything is I need to give it some data to operate on. So what I'm going to do is I'm going to give my image adapter class a constructor in a fashion similar to how I would give my base adapter a constructor so that it can accept the information it needs. In this case, it needs to get an array of images, an array of integer values in this case. So I am going to specify that this should get a set of images, and it will be an array of ints, because resource IDs are integers. Thereafter, I will store those images as a property, and this can of course be private. You should always get in the habit of making your properties private if you are able to do that. That is, the property is not going to be accessed externally. And in the case of my adapter, it will not be accessed externally. Only the functions defined inside of my class will access this collection. Now I can go ahead and implement the simple stuff first. So get item count wants to know how many views can this RecyclerView, or how many views can this RecyclerView adapter generate. Similar to when we're implementing a base adapter, this is simply a count of the number of items in my collection. Again, it doesn't have to be. We can in fact create relatively complex adapters that are able to generate more views than it finds in a collection, or generate views without a collection. But the vast majority of times, sure, it's basically just for every item in a collection, you're generating one view for that item. So this is what we tend to have. So I'm just returning the size of the collection images, which is my array, as the number of items that can be generated. Now I have here two functions, on create view holder, on bind view holder. And this essentially is how the adapter for the RecyclerView does that separation, where when you create a view is separate from when you give that view, set the properties of that view to match the items of an element in your collection. So on create view holder basically asks you to create a view holder that contains the view that will be displayed in the RecyclerView. You are only asked to create the view. You are not being asked to set any of the properties that will change based on the element that the view is displaying. So we want to make a distinction here, because not setting the properties for the item that will be displayed doesn't mean you can't set other properties. So properties that will be fixed, such as the size, for example. And since in this case we want to use or create an image view, then being able to give a size is important. And we can appreciate that the size is not going to change. What we want is some consistency. So every time we display an image, regardless of what image it is, we want it to have the same size. We want it to look uniform. So I am going to create, first and foremost, a view holder, an image view holder object. So I'm going to have an image view holder. Now, my image view holder wants an image view. It's going to accept that image view as its constructor. So I'm just going to go ahead and do all of this in line. So it's going to accept an image view holder. My image view holder is going to accept an image view. So I can just go ahead and create the image view that it's going to accept. Like every view type, an image view needs context at the very least in order for it to be created, in order for it to be instantiated. Now, you'll notice that we did not pass in a context object to our image adapter, and that is because it is common practice to access the context property from your parent object. This is a view group, essentially a reference to the parent, the recycler view that you're going to be displayed in, that is to say this image view. And this recycler view will have a context object. So we are able to simply access parent.context. And that's how we get a context object. So now I have an image view that is being passed into our image view holder. And in theory, I could just return this, whether with a independent return statement, or as you might be able to see, I could just return this item as I created. I don't need to store it in a variable first just to return it immediately. I could just do my return right away. Let's see if we could get this indentation a little neater. So at this point, I have an image view, and I'm almost done, except what I would like to do is give this image view a size, a width, and a height. Now, in order for me to do this in an imperative way, what I would generally do is I would store this image view object in a reference, in a variable, and then try to access the properties of that variable to set the necessary values. So I could do that. However, I'm not going to do that because it would force me to rewrite or refactor the code that I have here, whereas I'm having this single statement execute. If I needed to set these properties independently, I would have to refactor this. So what I'm going to do instead is use one of the scope functions that Kotlin makes available to me. Specifically, I'm going to use the apply scope function, which basically says execute the code specified inside of the function directly on the object and then return the object. So I don't actually have to store the reference to the object in a variable and then operate on that variable or the object pointed to by that variable separately. I can just tell Kotlin, hey, perform these operations on the object directly. So what I'm going to do now is set the width and the height. Now, it would be nice if I could just set width and height directly, but the reality is when it comes to dealing with views, such as an image view, the proper way to do this is to actually use what's called layout params. You will recall in our discussion about views that the height and width, as well as some other properties that a view can be given, or at least in the case of designing it at design time, we call them attributes. These attributes are specific, some of them, to the specific layout that the view will be placed in, the layout type. And each layout type has a layout params class that defines the set of attributes that views placed in that layout will respect or will need to have for the layout to know what to do with them. So in order to give a view a height and a width, the proper way is actually to assign that view a layout params object, not instead of setting the width and the height directly. So what I'm going to do is give my layout, set this layout params property of the image view by creating a generic layout params object. This layout params object has a series of constructors. One of them is one that takes a width and a height. So I can simply specify, let's say 300, 300. So that's 300 pixels width, 300 pixels height, and that becomes the layout params object that is assigned to my view. So I'm doing this every time I create a view because this doesn't change. I always want my image view, whether it's new or recycled, to have this value. So I do that at the time I create the view, and I create the view at the time I create the image view holder. So that's essentially creating the thing that will be displayed. Now, in order for it to know what data should be displayed in the view, we will now look at our onBind view holder function. The onBind view holder function accepts an image view holder and a position, which is essentially an index for our collection, for which we should extract an element and then use that element to set the properties of our view. So essentially what will happen is at some point we will be handed an image view holder that we had previously created. Whether or not this is a view holder and a containing view that is brand new or one that is being recycled is irrelevant to us. The layout manager is going to be concerned with whether it's new or recycled. And that's the beauty of it. We don't have to be concerned with where this object is coming from. All we need to know is we're given an object, we're given a position that we will use to fetch an element, and we just need to set up the properties of the view that are contained inside the view holder. So for us, that basically looks like this. Holder, which is going to be an image view holder, and my holder has one view inside of it, an image view. That image view has a resource ID property, so I'm going to call set image resource, and it's asking me to pass in the ID for the image that should be displayed. So it wants me to give it a r.drawable.something ID. Of course, I'm going to give it the ID that is inside my images collection at index position. So whenever onBind view holder is called with a view holder passed in and a position that I should use, this code gets executed. Again, I don't care if it's a new image holder with a new image view or a recycled image view. My job is simply to set up the view that's inside of it. And again, my view holder is very simple because I only have a single view. If I had a more complex view, maybe a layout that had different elements, then first they would all be enumerated here independently, where I might fetch different views from the layout file. And then in onBind view holder, I would set the properties of each of those views independently. So at this point, my image adapter is essentially complete for what I'm trying to accomplish right now, which is I just want to see my images. So I'm going to go next to my main activity, and I'm going to try to use my adapter. So I am going to give my RecyclerView an adapter. The adapter that I'm going to give it is an instance of my image view adapter, or rather my image adapter. And that image adapter wants, as an argument to its constructor, a collection of, well, technically an array of ints, which for us is the array or the collection of image resources. Now, this, it turns out, is not enough for our RecyclerView to function. In fact, if we were to run this application as it is, at this point, it's incomplete. And now we see that it's essentially blank. The reason it's blank is because while we have provided an adapter, no views will be displayed in a RecyclerView unless and until it is provided with a layout manager. So it's the layout manager's job to extract views from the adapter and display them in the RecyclerView. So there are different layout managers available to us. For example, a linear layout manager, which needs a context reference, will display the child views, in our case the image views, in a linear fashion, top down or vertically. So giving a linear layout manager such as this, now when we run our application, we will actually see our images being displayed. And here we can scroll through and we see our collection of images with 300 width, 300 height. And I could now switch this linear layout manager to say grid layout manager. And our grid layout manager will take as an argument context. And then we can specify something like span count, which is essentially how many columns should you have. So I could specify 2 columns. Running our application now, this single column display is now replaced by a 2-column display. And we can use other things like staggered grid layout, etc. So this is essentially how we are able to create a recycler view. We start by placing the recycler view on our layout. We then create an adapter that extends RecyclerView.adapter. RecyclerView adapter takes a generic reference that it uses to complete its body. That reference needs to be of type ViewHolder. The ViewHolder's job is simply to enumerate and provide access to the various view elements that each view entity, and I say entity here because you could have something like a layout file that itself contains multiple view items, each view entity will contain. Once that's defined, we override 3 functions. Item count will simply return, in the simplest case, how many items are in the collection. On create view holder is responsible for creating the view that will be displayed inside the recycler view and places that view inside of an image view holder or a generic view holder that is then returned. And then onBind view holder is responsible for setting the properties of the views found in the view holder. Once that is defined, we provide an instance of that adapter to our recycler view along with a layout manager, and we have our choice of a collection of layout managers, and each one provides us a different function, such as linear, which essentially replicates the list view functionality that is now deprecated in Android, and the grid layout manager, which provides us with the grid view functionality that is also now deprecated in Android. So the Recycler view has essentially replaced those deprecated view types. So this is the first responsibility of our Recycler view, drawing yourself. We are able to create a Recycler view that shows something on the screen. What we're going to look at next is the second responsibility of a view, which is responding to events.